Hello and welcome back to Intro to Cognitive Science. Okay, we have established a baseline for the field of cognitive science in its sort of primordial state, long before things have fully come together. We have interesting tidbits from different pockets of study. We've got psychology evolving through its behaviorist phase and into some more interesting concepts of information processing. We've got the beginnings of neuroscience touching the edges of information processing capacities. We've got theory of computation from our friend Alan Turing jumping into the giving birth to the world of computation theory. So today we're going to talk more about things as they've begun to develop towards a more coherent idea of the field, right? So we've got the seeds for studying cognition. We've moved away from strictly associative understandings of human behavior, right? So not just the behaviorist stuff. We are on to something a little bit more asking questions about what's going on internally, right? And to be clear, we do still absolutely form associations. We are still subject to the kinds of things that happen in classical and operant conditioning. But we are a little more complex than just those things, right? Another seed is, again, the theory of computation. We've got this model for information processing in a physical way, in a way that doesn't need any special insight to understand information and how it changes and is moved around. We have a way of physically capturing an algorithm and having it execute, i.e. modern computing, but at the time, this was the theory of the Turing machine. And then we've got a little bit more insight on information theory in psychology itself. What's the nature and the limits of our ability to handle certain amounts and kinds of information in our processing, in our brains, in our physical brains, right? So let's talk real quick about language, but in its sort of ethereal beginning state, basic communication. Think about animal communication. It is this very useful tool. We all need to be able to communicate, right? Social animals have a kind of a variety of calls that they can use to signal all kinds of things. Goats, in particular, they use what are called contact calls to just kind of keep track of each other. If it boiled down to one sentiment, it was, "Hey, I'm far away." Both in the way of saying, "Hey, you need to catch up," but also in the way of saying, "Hey, I think I'm falling behind," right? Now they don't process it like complex language, of course, but they do keep, this information is being transmitted, and it serves these very important purposes. But it's quite rudimentary, right? They're not conjugating verbs, and they're not communicating and transforming complex ideas. They're just being goats and using these particular calls for specific effects. Here's a video. Audio warning. It's a little loud, of some goats using these contact calls. Okay, we can leave it at that. So, what is this doing? A friend of mine, an old friend of mine, Lisa O'Brien, is an active researcher in this field. She's sort of in a highly interdisciplinary subset of the field. She works on understanding how goats and other animals, she's also worked with primates, but how they use these in social settings and what are the dynamics of these things. So, for example, here's some of her data. You don't have to totally track with it, but this is plotting the average distance of a given goat and when its contact calls are emitted, right? So trying to understand how do goats actually use this. In the top case, if goats are sort of not especially near each other, they're not going to call that much, right? They're not far apart. They don't need to emit these calls to each other much. Whereas when they're further apart, they start using them, right? And she quantifies these things, tracking their GPS locations, doing some math to figure out when do these things happen. The question being, what triggers the use of this kind of language, right? Here is a video, I believe, just more of a GIF, but it's showing. It will show the emission of a contact call over the course of time, and we can watch it as the positions change. These goats are moving in a herd. The little blue bulb comes up when they are calling each other. And this is her data. This is the kind of stuff she presents at conferences. I love it. I love this stuff. It's great. You might not see the application directly, but if we can scale this up to larger sets of more complex social dynamics, it gets pretty cool. So this is baaing from those who are lagging behind. They initiate the calls, baa. And here is baaing from those at the center of the group, telling the ones far away, hey, you're way too far away. Come catch up. No calls yet. Here we go. See, there's one straggler, and somebody in the center of the group knows it. Oh, I guess it's not one. It's a handful of stragglers. And now they start to notice, and they come. They follow, because that's beneficial to their survival, right? So this is just a little primer on some of the ways that animals use communication, right? But animal communication is simple. They don't need very complex structures internally to handle this stuff. They only need simple rules to create this more complex group behavior. For instance, if self.distance from herd is greater than scary number, then self.yell for friendship, and loud is true. But they don't need to have a complex neural structure to handle this. That's only two little tiny bits of information that they're tracking, right? How far am I, and when should I yell? But so this is the idea that you don't have to have a rich internal life to use communication tools. Not saying that goats don't have a rich internal life. I'm sure they have something going on between those floppy ears, but they don't use language in the same way that we do. So anyway, this was just to prime get the gears turning on what purpose does language serve, and then back to our use of language. We're a little better at this, right? We can use abstract and complex language, not just ba. And there's an important thought here that this is our ability to use language is not just communication, even though we do use it for that, but it's also this powerful tool for comprehending our own thoughts, for moving our own thoughts around, for conceiving of our own internal states, your internal dialogue, for example. So let's expand on that. How might you do math without language? Ponder that a sec. It is, if you didn't have language, if we're just cave folk, and we just can't, all we can do is grunts, keeping track of abstract information about like numerical values, that becomes a bit of a challenge. So, for instance, developing the concept that 2 and 2 is 4, right? There are 2 of something, there are 2 of something else. Altogether, there are 4. we adapt that, we abstract that into the broader concept of addition. We understand that, oh, I can slot in more than just 2 to make something else. I could do 1 and 3 makes 4. Because we start to elaborate these ideas into something that is abstract and portable in a way. So addition might be abstracted from these basic ideas of 2 and 2 makes 4, and then multiplication just follows from addition, right? Oh, well, 2 and 2 and 2 and 2 and 2. How many was that? 5? 2 and 2 and 2 and 2 and 2. Yeah, makes 2 times 5. That's 10. So we can learn, we can build new concepts out of other concepts, right? And it's not just how we speak about these things, it's how we think about these things. And it all relies on this ability to bind up new information in language. So language in the head is this useful concept, and what some think is the major step forward that helped us learn abstract thought in general. So, it allows us to think about more than just what is in front of us, right? We can think about the relationship of 2 rocks and 2 rocks being 4 rocks, not just the fact that there are 4 rocks in front of us. And this is powerful. This lets us do all kinds of interesting stuff. It lets us come up with new ideas, so innovation. It lets us reflect on things that have happened, perhaps not even at this moment. It lets us make predictions, create. Math, science, art, philosophy, everything, right? It's all tied in some way to language. That's not to say that it rests entirely on language. That's not to say that you can't do any of this stuff if you lack language, but the capacity for language is really this idea of abstraction into symbols that we are very good at wielding. So how do we do this? Chomsky got on about the idea that there must be some kind of structure, right? There must be some internal structure to how we are wielding language, wielding these abstract symbols. And he never talked about a neurological system to achieve it. He just spoke about the idea that, well, this must be at least somewhere in the vicinity of the truth about this. So this brings us to a field that emerges, natural language processing. This is a branch of AI artificial intelligence, in case that wasn't clear, aimed at making programs that speak, quote, speak, right, and understand natural human language. The question is, how do we actually do this stuff, right? It's cool that we can, and it's recognized as a very important piece of how we manage to build abstractions of the world in our minds, right? But the question is, how are we doing this? And so natural language processing gives us models that attempt to do this stuff, right? There are kind of 2 branches. There's the applied branches, which are making systems that we interact with in useful ways, like Siri, right? I speak into my phone, it turns my sound wave into text. Siri also then does some small tricks on the text to try to understand it, that kind of stuff. And there's also the theoretical goal of trying to understand our own structures, our own systems better, right? So while we build the puppet that does cool things, we also better understand ourselves. This is a common theme across cognitive science. We are always building a better model of our understanding of ourselves while we're making cool, weird stuff on the side, too. So, to revisit an idea that we've talked about a little bit, another note on recursion. So it's this common feature in language. It's very important in computer science and just cognition generally. We sometimes apply the same rules at different depths. And sometimes processes can feed back into themselves to achieve new results. So a simple rule will build something more complex. For example, we talked about before in our discussions of language how you might have recursive rules that apply to parsing the syntax of language. So, for example, a noun might break into a noun and another noun, or sorry, a noun phrase might have a valid construction of breaking into a noun and a second noun phrase, right? This happened with buffalo, 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 but we won't diagram that out. So check this. The mouse ran away. That's fine. That parses, right? There's the mouse, which is a noun, and it ran away, part of its phrase. The mouse, the cat bit, ran away. This is still making sense. It's the same rule applied over again, right? We have a new noun attached to a new noun phrase. The mouse, the cat, the dog chased bit ran away. The mouse, the cat, the dog, the man frightened chased bit ran away. Okay, we're getting a little bit out of hand here. That's not a good sentence, right? We have some sort of implicit limit on being able to parse these things in wieldy ways, right? But the idea is that you can apply the same rule over and over and still have a logically consistent construction. This is just an important way to dig at these questions of how are we using language? What kinds of processes are we using on our language? And the takeaway here is it might not necessarily be a terribly complex one to achieve certain applied situations. So let's look at the applied side. Have you heard of ELIZA? ELIZA was one of the very first chat robots. So, that meaning it's an attempt at some kind of natural language processing, right? It was originally designed to aid in sort of talk therapy for people to make sense of their own problems. They could talk to this chatbot that would parse small things out of their language and try to get them to reflect on their own stuff. People kind of ran away with it because it was exciting at the time. It was fascinating to be able to chat to an artificial agent and get something back that resembled language. It's amazing. So it was able to parse the text that you gave to it, and it had small templates and some canned responses to just feed something back that you gave to it, feed it back out to you, or start a new thread of here's a new thought, here's a canned response to try and just keep the conversation going. If you want to play with ELIZA, you can. It's an interesting system that you just can Google ELIZA chatbot online. Here's one example I found. So it's a cool tool. But how exactly does it work? It's not doing real deep understanding of natural language, right? It's not a brilliant chat robot. It's kind of flimsy, actually. So let's look at some of how ELIZA parses your text. Here's an example conversation had with this ELIZA chat robot. Well, my boyfriend made me come here. Your boyfriend made you come here. And he says I'm depressed most of the time. I'm sorry to hear that you're depressed. Right? It's reasonable. It's within the scope of a normal conversation. But it's not really very complex what it actually is handling under the hood. It's looking for certain things like so belonging. Boyfriend made me come here. Okay. This is an easy solution for ELIZA. It can just reflect this right back at you. Your, as opposed to my, boyfriend made you come here. As in, go on, tell me more. It doesn't do anything with the information. It just took it and mirrored it straight back at this person who's talking, right? And then in the second case, he says I'm depressed much of the time. Well, I'm depressed is what ELIZA is looking for here. depressed is a negative state. It has to do with their emotions, their feelings, their potentially disease, if it's really, really deep. So what Eliza is looking for is, okay, that's a keyword that I'm interested in, and this is about you, so this is a negative thing. I'm sorry to hear that you are depressed. You are depressed, right? This is all the bot really does. So these bots originally they got a lot of play. They were quite interesting. They were exciting to see because they were handling they were language coming out of a machine. It's amazing. We might have thought these could, quote, pass the Turing test. Now we haven't talked about this much. The imitation game, right? The Turing test, as it were. Not the same. Not much to do with the Turing machine. It's more about artificial intelligence and the idea of whether or not a system is sufficiently confusable with a human, right? So if somebody makes the mistake that this might be human, something passed the Turing test. Eliza initially might have done it. So people would respond to Eliza like they were real people, right? Especially if you build in little tricks like having them delayed, all that kind of stuff. So nice development here. Now, also on the side, the Turing test is often talked about like it's some kind of gold standard for like understanding whether or not an artificial agent is, quote, intelligent. That's not really accurate. It's more of a bare minimum for a system to be considered intelligent. And also the goalposts on intelligence have changed in various ways, because sometimes AI systems are way more intelligent than we are, and sometimes it's totally not. So we'll talk about some of that as we go. But these things haven't gone away, though. Just because we've advanced and just because they were very simple kind of rote machines doesn't mean that they are not useful, right? Have you ever used a chat help system? For example, you ever have a problem with Grubhub, you go to their chat system, right? And you immediately get somebody talking to you. Theodore F. Yeah, I'm sure that's whoever their name is, right? Thanks for contacting customer care. Please give me just a moment to review your message. What do you think is happening here? There's an automatic greeting that takes no effort. There's none of your information is in here. It's just dumped straight out. Then maybe you said, hey, my food was disappointing. I didn't like it. So they have some basic feature recognition on the idea that, oh, you're disappointed. Okay. And then immediately they give you the baseline automatic offer is, I can give you 20% discount on your next order, right? There doesn't need to be a human here. Especially, I mean, you haven't even interacted with Theodore F. yet, Jeffrey Slater. Yeah, I don't know. This is a random photo from Grubhub. I neither know Jeffrey Slater nor am I Jeffrey Slater. But the idea is that this kind of tool, is really useful because it allows a system like these help systems, these help chat lines, to get the ball rolling on this honestly quite structured conversation, right? You're not going to have a wild tangent in the middle of a Grubhub help call, help text chain. It's going to follow the same basic pattern. A human does usually show up in these cases because you need to make sure that if somebody does have something above and beyond the super basic stuff and wants to elevate an issue or whatever, that person will show up, but they don't need to handle like 80% of these calls they get, these texts they get. So they automate those first steps. This can be seen as quite cynically a downslide for the way we interact with humans, but it's also, in another sense, why not? Why not keep some of this stuff automated, right? So, yeah. These tools are out there, I guess, is one of the keys I wanna put down here, is that this stuff is still used. Kind of basic pattern matching to try and give you the experience of being attended to, for better and worse, right? So, Eliza was simple, right? But modern versions are still around. There's more advanced tools involved. Sometimes there's actually more advanced, like I said, they did a sentiment analysis to realize you were disappointed, right? That has to do with analyzing the features of your text and the semantics of your words and la-da-da. Great stuff. Another example is Cleverbot. If you go have a conversation with Cleverbot, website there, Cleverbot's a little raunchy because it has every human on the planet is allowed to give Cleverbot things to say. But Cleverbot is just as kind of stupid, quote, as an Eliza bot is. It's just taking things that are said to it and regurgitating other things that were said to it in response, right? So, hello, how are you? That's pretty automatic, right? Whatever someone says after how are you goes into Cleverbot's repository. So you can have a conversation with Cleverbot and it will carry it on as long as possible. I tell you, it's not. You'll have some fun with it, touching, screwing around with it, but it's not that robust. So, these are basic text parsers, text chatterbots, right? They're simple, and the key thing here is that they are not even attempting to do actual linguistic processing. They're not actually trying to simulate language. Simulate in the sense of give you something that's reasonably language-ish, right? But they're not trying to simulate the process of changing language into something meaningful. It just takes these inputs, chops them up, and spits out reasonable outputs. The problem with actual language is that the domain is huge. Language is super complicated. It's got all these weird rules depending on what language you're speaking. There's a bunch of edge cases. The dictionary of all semantic meanings is interminable, right? So if we're going to try to capture natural language processing as a general idea, as the mechanisms involved, such that we could maybe get at. So if we understand the mechanisms, can we understand the brain mechanisms, the neurology of natural language processing, right? So Winograd comes along and comes up with this idea of, okay, we can't do all of language in the real world. What if we do some language in a micro world? This is Winograd's idea, SHRDLU. This is a way of trying to model all of language in a very small world. In a small world that is controlled and carefully pruned to only have a handful of meaningful things in it. You'll see what I mean. So the idea, again, as we've seen, try to treat language as this hierarchically organized, rule-governed, planned behavior, all this information processing, good stuff. But instead of trying to blow the doors off of it and do the whole world, use a micro world to restrict the problem, to give a small world's account of all the language available in that small world. Quick trivia about SHRDLU. This is interesting. It got its name from English letter frequencies. So linotype keyboards were originally organized by this. The most frequent letters were on the top left, and the second row after Iteoin was SHRDLU, right? So similar to QWERTY or something. So just a bit of trivia. Because it always comes up, why is it named SHRDLU? What is this about? So, what are we doing here? What are micro worlds about? So, micro worlds are virtual environments where all the objects, properties of objects, and events that can happen in that world are all rigorously defined. So, for instance, much smaller problem space than all of English. And it's great because it gives it gives language within this microworld semantic meaning, right? Moving an object is a concept about something that happens in the microworld. It's not just about the syntax, which is very important. Parsing a natural language sentence, the syntax of it helps you derive the meaning. And the meaning sometimes helps you derive the syntax we'll talk about. But it's used all over the place. These microworlds are great. Both in AI and COG Sci, what they're used for is to help demonstrate the sort of the base case, the simplest case, before you try to scale everything up to the real world. So if you limit the problem space, but you do all of it, then you're going to reach some conclusions you might not be able to reach if you're just going to focus on a very single piece of language or of this problem space, right? So, what is SHRDLU's microworld? Let's explicate. SHRDLU has 3 kinds of objects in the world: pyramids, squares, and boxes. Okay? They each will have 3 properties, or 3 that we'll talk about at least. There may be a handful more. What are the heights of these objects? What are the colors of these objects? I suppose it would probably keep track of the sizes, relative size. So width and depth potentially. But also, am I currently holding this object? Okay. And then it has a handful of actions. Find an object, pick up that object, or put down that object. So another element of this tiny world is that SHRDLU has a virtual arm. It's able to do things. So if I give SHRDLU the instruction, find a block which is taller than the one you are holding and put it in the box. Okay, so what is SHRDLU to do? On the left, we see that SHRDLU has this pink square, right? And it's going to determine, okay, I need to find a larger block, and it determines, oh, that's the blue one. Okay, I'm gonna put this box down wherever I can, go grab the blue box, and then my other instruction was to put it in the largest box. I flubbed this a little bit. Boxes and squares and rectangles and blocks and blah, blah, blah. Blocks are the solid objects. Boxes are the hollow objects that can have things inside them. So SHRDLU does this, right? And here's the key. That sentence, find a block which is taller than the one you are holding and put it in the box. Both you and SHRDLU understand that sentence to the same degree. You understand exactly what is communicated there. The semantics are all very clear to both you, the human, and me, the one talking, but also to SHRDLU, right? Because SHRDLU's world is so small that it has been able to model all of the language in that sentence in a meaningful way. So, this is the idea. SHRDLU is able to have conversations about its microworld in which it actually understands, quote, quote, the language. So, SHRDLU can have conversations. It can answer questions. This is cool. So if I ask, hey, which block is taller, the one you're holding or this other one, it will be able to answer that question. This block is taller than that one. It's able to resolve ambiguities, or at least request that you help with that, or it can try to do it on its own with a certain system that it has. So you said it in your sentence. You must mean the block that I'm holding. To pick it up and put it in this place. Pick up that block and put it here. It doesn't really have any content, so it has to infer that it means the thing that you previously instructed it to hold. It can do the instructions. So I say, hey, pick up the tallest block. It says, okay, I can do that. That's easy, right? And it can plan complex actions. In that last example, it realized that it needed to put down the other box so that it could pick up the next box that it needed, right? Or for example here, oh, okay, first I will pick up and move this pyramid so I can get to the box beneath it, right? It's able to understand the properties and relationships between the object and its world as well, while it's trying to make sense of the language that we're feeding it. And it even has the ability to kind of learn new terms, provided that you do it in a very specific way. It's not going to learn things all on its own. But yeah, so how then? I've told you what it's capable of doing, all the neat stuff that SHRDLU can handle. How the heck does it do that? So SHRDLU has a bunch of systems. It is an interconnected network of systems that all share information with each other. They transfer information around. Syntax systems, where it will pick apart the sentences, right? Very much like what we talked about before with context-free grammars and figuring out, okay, which referent touches which, and what is the structure of this? Where are the verbs? Where are the nouns? And which verbs pertain to which nouns? All that good stuff comes out of syntax systems. There's also some semantic systems, which say, okay, so box, when you say the word tallest box, I need to convert that to a referent in the world. Okay, so it has a state, it understands the state of the world. It's able to say, they said tallest box. I can look around for that. Okay, that one is the tallest box. That is the semantic meaning of tallest box. So, and it's able to do that about objects, its properties, the actions, all that good stuff. And then integration and action systems. So these are where things get a little bit more hairy and interesting, but we're not going to delve deep into them because I don't even know how all these things work. They're amazing, but you can dig into the paper later if you like. So this is where it integrates the ideas here, right? So this is where it might come up with more complex planning. So, oh shoot, I need to get that, but I can't just lift a box through a pyramid. I got to do something with the pyramid first. That kind of stuff. So integrating both the syntax and the semantics into something that is meaningful and realistic, right? So SHRDLU has these kinds of systems, and it has 12 altogether. And there's a little bit of hierarchy. There's some like top level systems that sort of strictly dictate what other systems handle, but there's mostly, it's a lot of crosstalk between systems, and we'll talk about why that's so key soon. There's no central processor. There's no one thing in charge of the way all this information is going to flow through SHRDLU, because that wouldn't even really make sense. There's so many different processes going on in how we make sense of the semantics, the way we make sense of being able to answer or perform an action, right? And these are all specific procedures, algorithmic procedures, right? It's very information processy, something that we are going to keep harping on forever in this course in cognitive science. So I can zoom in a little bit. So these are all of SHRDLU's units. It has a monitor that helps kind of integrate things. It has the input that it gets from the user, and it consults a dictionary of terms and ideas. The grammar helps make sense of the syntax. Then the semantics come in and help kind of make sense of what properties, what objects are we referring to, how might we answer things, how might we plan movement actions, all this stuff. So these are the distinct units of SHRDLU. These are the small subroutines that exist within SHRDLU and which things they talk to between each other. Okay, so just the big idea here is SHRDLU kicks in motion as soon as you give it input. The input will go to other parts of SHRDLU's network to get processed into something that eventually becomes either an answer or an action. Let's watch SHRDLU do that. I'm gonna mute myself. This video is a little tough to see at times. I hope it comes across. It's maybe one of the times that it's more beneficial to have it on YouTube than on a projector. So we're just gonna watch SHRDLU do some stuff. It's gonna have a little conversation. Okay, we've seen some cool things here. We're seeing it's able to talk about things that have recently happened. So the block I told you to pick up, that's a piece of information that SHRDLU can handle. It's also answering sort of declarative things, knowledge about the world. You know, can a box support a pyramid? Sure, SHRDLU knows. SHRDLU knows that. It also knew how to process the language to be able to say that to you. It's great. I like this. SHRDLU is a great example of shrinking a very difficult problem down into something that is tractable. Simplified artificial language playing out on this very small scale, right? But to be good scientists, we can't just say, hey, neat, cool, let's move on. We got to talk about the limitations. And even SHRDLU's creators know about its limitations, but let's talk about the limitations that it did have. Had some negative press at the time. Not press, but science press, you know. So here's a couple of things. SHRDLU is missing a big piece of human language generation, and that is humans will speak spontaneously, right? So SHRDLU is strictly reactive. Now, we know that. It's just a program. It's just going to sit there and wait for content to be fed into it. It can't understand much in the way of context because there's not... it doesn't have the ability to consider broader context. I mean, it is in a microworld, of course, but that's pretty big, right? If I told you certain instructions while you were on a street corner versus in your bed, those are two wildly different situations, right? It couldn't differentiate that. Not that it could be in multiple situations. It has a microworld, but that's a key idea, right? That's something from real language that is very important that SHRDLU cannot address. Questions and statements only, so it doesn't have just like basic conversation, which honestly has a lot to do with it being strictly reactive, right? It's only got a very simple version of grammar, so natural languages have a lot of complex, strange things going on with grammar sometimes. The man, the bat, the cat, the heart, the bark, bat ran, hid from the guy, right? I know, that was nothing like the sentence we saw earlier. I just was off the cuff. But SHRDLU doesn't do complicated grammar. It just was very simple grammar. So not everyone was a fan. And I like to highlight some of the historical discourse and some of the ways it was a little bit nasty, because everybody likes a little bit of a juicy story. Let's see what Hogland thought of SHRDLU. SHRDLU performs so glibly only because his domain has been stripped of anything that could ever require genuine wit or understanding. Neglecting the tangled intricacies of everyday life while pursuing a theory of common sense is not like ignoring friction while pursuing the laws of motion. It's like throwing the baby out with the bathwater. A round, frictionless wheel is a good approximation of a real wheel because the deviations are comparatively small and theoretically localized. The blocks world approximates a playroom more as a paper plane approximates a duck. Dang, man. That's academies for screw you. Now, hang on. Hoglin's points are valid. He was pretty colorful in his discussion here, but microworlds aren't the real world. That's what his point boils down to, and it's a big one. That's not just because we're kind of like, hey, man, slow down. It's just a toy computer program. But his point stands that SHRDLU cannot model the real world, right? The common sense way that we use and wield language outside of ourselves, outside of microworlds that we might interact with, that kind of stuff. So, but the defense of SHRDLU is that, of course, it can't. It's not a model of common sense language. It is the model of the way one possible language works in one possible micro world. So it demonstrates that at least this particular model of language in this very limited setting is plausible. And it allows us to look at some of this stuff in a much more robust way than if we just said, oh, it's intractable, let's never try, right? So, Hoglin's point stands. This is science. It can be both. Cognitive complexity implies that you can hold two contrary ideas in mind at once. Not everything is who wins. Remember that, please, everybody, as you go out into the world and web forums. Holy crap. So, SHRDLU is doing some cool stuff, but it's not addressing the real world. But what are some of the really cool things that it can handle? So, SHRDLU highlights this interesting tension between syntax and semantics. It shows how in those integrators, right, some of the integrating functions that SHRDLU has, sometimes to make sense of syntax, you have to have the semantics available. What does this mean? Well, in the world of linguistics, we've kind of drawn lines about, well, semantics and syntax are both quite interesting, but let's talk about them separately. But in some cases, you need to have them both. So, put the blue pyramid on the box put the blue pyramid on the block in the box. Okay. There are two possible meanings to this sentence. So does that mean the pyramid is going from the block to the box? Or is it the pyramid going to the block in the box? Put the blue pyramid on the block in the box, or put the blue pyramid on the block in the box, right? The only way to understand this is by consulting the actual world. Which one of those is extant? Which one is possible? Which one is real? Which one has real semantics tied to it? One, in theory, could make sense, but only one of them is going to be the real case when you look at the world, when you extract the semantic meaning from your knowledge of the world state, and then try to parse the sentence again. And that's how SHRDLU works. It does this. It's able to say, oh, only one of these things makes any kind of sense, so I'm going to go with that one. Great. That's cool. So, big successes of SHRDLU. It's a practical implementation of generative grammar rules, right? It's the deep structure of syntax kind of made explicit in a system that actually does it. Ooh, great. So how we algorithmically represent both the rules and the knowledge required to process language, that's awesome. And also showed how you can break down the information process, or a cognitive system, both kind of interchangeably referred to here, into component processes. Component processes that talk to each other. They run parallel. It's not just top to bottom, left to right. It is a whole bunch of information units all babbling, all trying to make sense of the input. Hey, this is the syntax. Oh, here's the semantics I found. Oh, let's combine them, right? It's not quite as, anthropomorphic as that, but that's the idea. Breaking things down into a parallel distributed process. That's big. So, and altogether, it gives this algorithmic information processing account of how language can work. That's great. Fantastic. So, SHRDLU altogether. Language is a complex skill that most humans possess, right? Almost all of us come to possess this skill at some point. Not every single person, but it's sort of fundamental to our species. We are able to get this quite easily. And it may even be a critical component of complex thought. So trying to address how it works was a pretty big thing to try to tackle. And SHRDLU comes in and says, here's a tiny version of that. Let's look at it from all angles and see what we can infer, right? And what we can infer, what we achieve with SHRDLU is demonstrating how language can be broken up, stored, transformed, processed, distributed, and converted into meaningful actions, which ultimately, that's the powerful part of language. The goats can call each other home so that they don't get separated. That's pretty useful, right? So, final thought. What's another complex problem that could be boiled down to a microworld version of itself to help make sense of it? All right. Thanks. Take care.